Hello everyone, my name is Bogdan Boteanu from University Polytechnic of Bucharest, and I will present you our approach to MediaEval 2016, Pseudo-Relevance, Feedback, Diversification, Perspective. The approach consists mainly in 3 steps. The first one is to select the positive and negative examples, which is actually the pseudo-relevance part, in which the human is substituted by the computer. Then we perform a hierarchical clustering algorithm to group images based on their similarity. The hierarchical clustering is then followed by a pruning scheme in which we remove irrelevant images. And finally, we perform a diversification, which is achieved by selecting the images in each class that we obtain from the hierarchical clustering with respect to their initial ranking. In the following, I will explain you each of the 3 steps. The first one is the selection of the positive and negative examples. We have the ranking of the flicker for each query, and we select the first images which we assume that are relevant, being the positive examples, and we also select the very last retrieved images which are considered to be irrelevant. These assumptions are based on the fact that on Flickr we have 35 out of 50 in the first retrieved images which are relevant. So we made this assumption, which is actually the pseudo-relevance part of the approach. In the following, we use these selected images, the positive and negative examples, and we fit them to hierarchical clustering, more precisely agglomerative hierarchical clustering. Basically, each image starts from its own class, and iteratively they are grouped based on their similarity until we have one big cluster with all images. So the algorithm yields a dendrogram of classes, and for a certain cut point we obtain the clusters. Further, we use the number of the positive and negative examples in each class, and we evaluate each class to be relevant and or unrelevant, so that if we have in one class more unrelevant images, there is more negative examples than the positive examples, we declare that the class is unrelevant and remove it from the final list. Then we use the resulting relevant classes from the previous step. We use it in a diversification scheme. On the columns we have the classes obtained from the hierarchical clustering, and in each class we order the images according to their initial ranking from Flickr. So we traverse each class and select the first images to have diversity, and go down and select the other layer to have relevance, to obtain relevance. In the end, we'll have a final ranked list of 50 images, which is the final output. In the following, I'll present you some parameter tuning used in our approach. We varied the number of positive examples from 100 to 280 with a step of 20. We also varied the number of negative examples from 0 to 20 with a step of 10. And also the inconsistency coefficient, which yields the number of classes, from 0.5 to 1.3 with a step of 0.2. And we selected the best combination of these parameters, which yielded the highest F1 metric score. We used this on DevSet. In this slide, I will present you the results we achieved on DevSet. We had 5 runs, namely visual textual, credibility, and all together, all features provided by the organizers. What we can see is that we obtain on DevSet best performance for textual and all visual and all together features. There is a common feature, which is textual information, which we suppose that yielded the best result. On DevSet, we applied the same combination, which yielded the highest F1 metric score on DevSet, and we obtained the best precision for textual information. In terms of cluster recall, the best performing was using the all credibility information, and the overall was using also the all credibility information. That was surprising for us because on DevSet credibility information didn't yield so good results. In the end, we came to the conclusion that the credibility information was useful in our overall diversification, and it was outperforming the other types of descriptor with more than 20%. And in terms of F1 metric score, we also obtained better performance over the other types of descriptors, by 2% over the text descriptor and by 6% over the CNN, which is deep learning features. Thank you for your attention.
Thank you.